Okay, let's get started. So here, your quiz fives are up here. You did excellently on them. The average was over 100%, so good job on that. Yeah, so feel free to pick them up. Please, in fact, I encourage you, please pick them up. So what's on Friday? Test. So any questions about the test? Yeah, so I updated the document, right, it says right here I did. So basically up through member init lists, which we covered on Friday. So basically everything we did through Friday. So nothing on inheritance or anything like that. So it's, let's see. So through slide 34 on the last set of slides. So nothing on aggregation, I don't think. Oh yeah, never mind. Aggregation and composition, so through slide 36. Yep. But there's no programming on, no explicit programming on the test, but you should be expecting to see, okay, here's a piece of code, then write something about that piece of code. You're not going to write code yourself on the test. Yeah. No pseudocode, because we're at the point where we can get away from like all the details of the language, but we can now start to look at bigger pictures and say, I have this problem I want to solve. Should I use this method or this method? Or if there are many methods, which one's the best? Which sort should I use for this situation? Should I use aggregation or composition in this situation? Should I, what operator should I overload for this situation? That sort of thing. So being able to think at a higher level, what should be the best way to approach a particular problem? That's what I'm trying to get toward here. Any other questions about the test? Okay, any questions about the assignment 7? Yeah.
Can you go over number 2?
Oh, you mean in the quiz? Sorry. Yeah, I haven't uploaded the solutions yet. I will today, I promise, because I haven't fixed the questions. So you mean question 2 or subpart 2?
Subpart 2.
Okay. So there's a whole lot wrong with this, unintentional and intentional. So one of the things that was wrong is that numbers is not the same thing as nums, and so that's an error automatically. That's unintentional. The third element is, should it be a +3 here? No, what should it be instead? +2. So that's another unintentional error, and some people pointed that out and got full credit for that. But what's the real thing that I wanted you to see? Put parentheses. So I wanted you to say, oops, get rid of this. So I wanted you to say this instead. So the +3 is my error, but I wanted you to put parentheses around here because numbers is a pointer, and we wanted to do pointer arithmetic, not find what the value is, then do a +3 on the value, because I wanted to look up the third element, not the first element +3 or whatever. Does that answer your question?
Yeah.
Other questions about the quiz or whatever? Yeah.
So if you didn't write anything for 5, did you get it wrong?
So if you didn't write anything, then I assumed that you just didn't try in the question, so I gave no points on that one. But I wanted you to actually write something, or at least try to attempt it. Other questions? Yeah.
I know it was just a bonus, but you go over number 3.
Yeah. So the scenario, by scenario, I meant not restating what unique and shared putter actually do, because like a scenario could be, if I only need one owner to this object, I should use unique putter. But that's saying what unique putter does. It doesn't give me context as to why I should use unique putter over shared putter. So a scenario is, I have some problem here's the problem I want to solve. Unique is better because of this reason. So unique putter is better in the situation I have here because for a student, the array of courses that student has taken is unique to that student. Hence, we should use a unique putter for that array. For shared putter, you could always emulate it with a bunch of unique putters, but that's not the right idea. So if you have a lot of objects, say students attending the same university, then they should all have a pointer to this university object. And so therefore, it should be a shared putter in that case, because a lot of things are pointing to the exact same object. So a shared putter is better in that case. So a lot of people just basically restated what unique and shared putter do. What I wanted you to have is a scenario where a unique putter is better. What problem does a unique putter better solve than a shared putter does? Okay? Other questions about the quiz itself? Or assignment 7, for that matter. Yeah?
We only need 3 graphs.
So on assignment 7, you'll have 8 plots for each of the 8 vectors, but you're running each one of the vectors through each of the sorting algorithms, right? You're running, say, V1 through bubble sort, selection sort, and standard sort. And so you're going to have, for V1, for example, a bunch of points of, say, okay, for bubble sort, it took this long for 10, this long for 20, this long for 40. And so you have a scatter plot or a curve if you want, but really a scatter plot of points as to say, oh, bubble sort is trending like this, selection sorts like this, standard sorts like this. And then you'll have those 8 plots for each of the 8 vectors. So basically you'll have 24 lines because you'll have 8 plots and 3 per plot. Other questions? Yeah. Here?
For assignment 7.
Oh, okay. So assignment 7. Yeah, what part?
Part 7.
Oh, yeah, here.
Can you explain exactly what you mean by not changing the vectors?
Yeah. So here, not change the vectors. What do you think I mean by that? So, yeah, go ahead.
Don't create a new vector every time.
You mean I should create a vector every time? Because if I pass in the same vector to the sort algorithm and I take the vector by reference, then once I sort it once and I'm going to pass it in again, it's now sorted again. But that'll throw off the algorithm potentially. So what I wanted you to do is, instead of passing in by reference, pass it in by value. Okay? Well, that works for bubble and selection sort. But standard sort you don't have any control over, right? Because it's already written in the library. And that takes it by reference. So what should you do? You can't do anything about it, right? So what could you do instead? Create a copy of the vector and pass in the copy. Okay? So for standard sort right here, I don't mean you to pass in V1 into the vector, into standard sort. I want you to pass a copy of V1 and pass that copy of V1 into sort, not V1 itself. And you can do the exact same thing for a bubble and selection sort if you want to, but for standard sort you have to. And so you may think, well, okay, that's going to throw off the timing. For this assignment, it's okay. But think about the copying of the vectors is going to take some time to actually do. So how would you actually get rid of that time that is allocated to copying rather than just the sort algorithm? Because I can't just pass it by reference because I can throw off the result that way. So that's just something to think about. But here, modify the original algorithms means pass it in by value and not by reference. Other questions? Okay, so last time, way back on Friday, before the long weekend, we were talking about a whole bunch of stuff. So convert constructors allow us to convert from one type to another. Then we talked about ways to have some classes built into other classes. So for example, I could have an, let's go back to this example. Let's just say we have an ASU employee here, and then some variable that we have in here, let's just say is a string s. And I have to include IOStream for this to work. But basically, this is taking one object and then putting it into another. So in this case, an ASU employee, let's just call it ID. An ASU employee has an ID. Okay, it has an ID. Okay, so that's basically aggregation. Composition is slightly different, where you control the lifetime of the object. So if you have an internal array that you allocate dynamically, say you allocate it in the constructor and delete it in the destructor, that is composition. Basically, any form of objects that we handle in this class are basically composition anyway, because string, or pretty much any object you have used so far, handles that dynamic memory allocation itself. It handles when it's created and when it's destroyed. And string is no exception here. Then we talked about member init lists, which allow us to initialize some of the objects that we are holding easier. So for example, I could have a constructor in ASU employee constructor. Let's just say it takes a string, an ID, it passes in an ID, and I want to initialize our own ID with the one that was passed in. Well, the way that we've been doing it so far is this, where we just say our variable is initialized to this thing, to the thing that was passed in. But a better way is to use member init lists, which is with a colon, the thing that we want to initialize, which is the ID with no underscore, and then put into here the thing that we want to initialize it with. So here, I'm calling the constructor for ID, the internal variable that we have, with the value that was passed in. So here, I could have a complex object in here and then just call the constructor right here. This is way easier than initializing everything within the constructor. So member init lists are really nice. And if we had other objects in here, let's just say let's just say we have an int num courses taught. Then maybe we can have number. No, oops, can't type. Num courses taught to default initialize to 0. So I'm calling the constructor for the int here, and I'm passing in the value 0 for this integer. So this member init lists are a nice way to initialize variables accordingly. Okay, so so why do we have this? It makes it a lot easier. Okay, so then last time we just started talking about this topic called inheritance. Inheritance is not on the test, so don't worry about that. So the entire point of inheritance, does anyone remember why do we have inheritance? I think I mentioned it. Okay, it was a long weekend, you may forget. So inheritance, the entire point of inheritance is to reduce code duplication across classes. Okay, so I will have some code in one class, and I don't want to have to retype it for another class that basically is a version of the class I had before. So inheritance is saying, I have some object A right here, some class A, and some other class B, And the class B is a class A, not has a anymore, is a class A. So, like, for example, you can have a class vehicle and then a class car, because cars are always a vehicle. Is a vehicle always a car? No. So is a one-way street. So one thing is another thing. So inheritance allows us to say, I'm going to put the code that is going to be shared by these classes inside this parent class, as it's called. So the vehicle class is going to have some code as usual, but the car class is going to inherit all of that code automatically, so you don't have to retype anything. And the good thing is that anything that is unique to a car, you don't have to worry about any other vehicles because it's unique to the car. But if it's shared among all vehicles, you might as well put it in the vehicle class, because then car will inherit it. So the vehicle class is called the existing class, or base class, or parent class, or superclass. So there are a lot of names for this, but the one I'll probably use is base or superclass. But they all mean the same thing. So vehicle is the base or the superclass. Okay? Superclass, the best class of all, right? So the one that we inherit things into, the car class, that is called either the new, derived, child, or subclass. I'll call it derived or subclass. So the vehicle class, is it the base or the derived class? The vehicle one is the base class. And the car class, is it the base or the derived class? It's the derived class. So the thing that we inherit from, that's the base class. And the things we inherit to are the derived or subclass. So how do we actually do this in C++? So we make a base class. It doesn't have to be called base. It can be called whatever, but we just make a normal class, nothing special. And then what we do is say, okay, I'm going to make a derived class, and this colon right here is going to say, I'm inheriting from some class. And what class are we inheriting from? Base. This public, don't worry about it yet, but basically we're inheriting from the base class. So this is one way we can say the same thing, but in a pretty picture. So we have a base class up here, derived class down here, and the arrow says, the tip of the arrow is where we're inheriting from, the base class, the tip of the arrow. And the tail of the arrow is where it's going to. I don't know why it's like this. It should be the other way because it's going from one thing to the other, but that's lost to history. But the important thing here is that we're taking from the base class and going to the derived class. So what things can we actually inherit from one thing to the other? So a parent class up here has an int a, some function bf, and then the parent class obviously has that integer a and that function bf. So if I make a parent object, I still have access to everything that the parent class has. There's nothing new there. But if I have a child class, which inherits from the parent class, I get both of those things as well as the things that are unique to the child class, which are what in this case? What things are unique to the child class? The C and the df function, right. So the child classes, the objects of the child class have access to all four of these things. Whereas if you only make a parent object, you only have those two, the A and the BF. Okay? So that's just basically how inheritance works. I'm reducing code duplication from one class to the other. I didn't have to retype everything from the parent class into the child class, which is really cool. So where would you actually use this instead of having like vehicles and cars and whatnot? think of the vector class. Wouldn't it be really nice if you had a vector-like object that automatically kept its elements sorted? So I insert whatever object I want, it keeps everything sorted for me. So then one thing you can do is say the vector class is the parent class, and the subclass is to say, I'm going to change the methods of inserting a value to say, I'm going to do the insert normally as the vector normally would, and then immediately after call sort on the vector. And so I can have a really simple implementation of a sorted vector based on the vector class. I didn't have to redo everything in the vector class, only the things that needed changing. Okay? If anything else needed to be added to it, I could add it there as well. So it reduces code duplication among classes. So is inheritance a has a relationship or is a relationship? May have been a fluke. Has a or is a? Is a, good. The child, although this is kind of weird, the child is not a parent. I hope. I hope children are not parents. But unfortunately, this is the notation that was used. Think super up here and then subclass down here. The child inherits everything from the parent is probably the better way to think of it. But based on this interpretation, children are parents, unfortunately, yeah. Yeah, so I can have something inherit from child, something inherit from that. I can have inheritance chains all the way down. One thing that's actually really unique to C++ is that I can inherit from two different classes at the same time, which is pretty cool. There are some downsides of that, but basically you can have almost anything you want. I can inherit from multiple classes at the same time. I can have chains of inheritance all the way down, that sort of thing. So where would you actually use this sort of thing? So I made a simple example. Let's get back to where it was before. And then let's see. So let's have this function public right here. And I have a ASU employee class up here. And I have a public function f. It's just an arbitrary function. Doesn't really do anything because there's nothing in there. And here I say an ASU instructor is an ASU employee. Okay? So anything that ASU employee has, I'm going to inherit in the ASU instructor class. Okay? So I'm going to make an ASU instructor called myself, and then I'm going to call f on it. Is f defined in the ASU instructor class? No, where is it defined? In the parent class, the super class, right. So it's defined in the ASU employee class, and ASU instructor is inheriting it from the ASU employee class. And we can actually see this actually working. So let's say that in this function, we're going to print ASU employee to really say, yeah, we're in the ASU employee class. But if I put it down here, maybe this works. Let's put ASU instructor down into here. And then if we try to run this, you can see that there's an error right here, right? Here we need to actually make this public for ASU instructor. But let's just see what actually happens if I did this. Then it prints ASU instructor, so it really is calling this different version of f, not the one that was in the parent class. But if I remove this entirely, then what do you think this is going to print? ASU employee. And we can actually verify that this is the case. So it first says, okay, do I have a different version of this function in my class? If I do, then I definitely will call it. If I don't, I go up the chain one level to say, is it defined differently up there? If not, I keep going up until I eventually find it. So the f function, it said, okay, it's not defined anything different in the ASU instructor class. I'm going to go up one in the chain and say, oh, it's defined in the ASU employee class, and there's nothing else it's inheriting, so I'm going to use this one. Whereas when we had it before, it immediately looked in the instructor class and it said, oh, I found it here, I'm going to call this one, and not have to go to the superclass. Okay? Anyone have any doubts on this? Yeah.
Not exactly doubt, but
Yeah.
so if you're defining number functions outside of the class declaration, you need the colon. So if you say class ASU instructor colon public ASU employee colon function name.
Yeah, so the way that you use the resolution operator, the double colon, you have to put the class that it's relevant to. So if I did this just for ASU employee, let's actually do this. So if I put employee out here, and then I have a void f, just a prototype up here, then I need just ASU employee. If I just did ASU instructor down here, then all ASU employees won't get this function because it's only defined for the instructor. But if I wanted to, I could say, I'm going to copy this function, redefine it for ASU instructor, and then change it to different function, something like that. But I need to redefine the function, of course, in the ASU instructor again. Any other questions on this? Yeah.
So there was like a superclass that had subclass needed like a lot of code from. Would there be a way to get only like a part of the code from the superclass not included?
Yes, and we'll see a way to do that. Other questions? Although it doesn't really make sense there because something is a something else, so you shouldn't inherit everything, but there's a way to fix that. Other questions? Okay, so let's get back into here. So if you do some dynamic memory allocation, there could be some problems. This isn't really that important, but it's just, let's see. So should be created using dynamic memory and access via pointers. So it says objects should be created using dynamic memory. I'm not sure if that's true, because if you have a small enough object, there's not really a reason to allocate something to the heap, but that's what they say here. Okay, that's actually really interesting, this point right here. A method that expects an argument of a base class may not have the space needed to accept an argument of the derived class. But something that's really hidden right here is a method that expects something of a base class. So let's just go back to our example here, and then let's not have any of this code. Let's just have two empty class definitions. It's not really important. Let's just say we have some function out here that takes an ASU employee. And let's call it E, and then maybe it does stuff in here. It's not really important. Can I pass the Ryan object to this F method? It says it takes an ASU employee, but I'm putting in an ASU instructor. Is that okay? Yeah, why? Because an ASU instructor is an ASU employee. So everything that is needed to make an employee object, the instructor class already has all of that because it's inheriting from it. So we can have some generic object right here to be passed in, as I'm expecting some ASU employee, but any employee can be passed to this function. If I had just an ASU instructor as the argument type, could I pass an arbitrary ASU employee to this function? No, because it's expecting an instructor or any subclass of instructor. But if I just left it at ASU employee, then either any ASU employee or any subclass of that can be passed in. So we're not there yet. But basically, just know that if you stick with the highest level of generality for when you make functions and whatnot, that's going to be best for anyone who uses your code. Because then they can pass in any subclass that they want that's specific to their needs. But if you make it as specific as possible, then it may cause problems for them because they may need a superclass of the one that you passed in. So if you said only instructors can use this and they want to use an employee, that may cause problems. But stick with the highest level of generality you can. Okay, so the question that was asked earlier was, what if I wanted to have some code that was passed along, but not everything? So if we go back to our example, let's just have a void f function right here. Actually, not in instructor. Let's have it in employee. So let's just have this function right here. What is the access specifier by default for classes? Is it private or public by default? Private. So is f private or public? Private. So ASU instructors are ASU employees. So should ASU instructors get F? They should. But if I try to, let's just say, have a different function right here, and then I try to call it, then I can't actually call it because F is a private member of the superclass. What does private actually mean? Can anyone tell me what the word private actually means in this context? It means you can only access this function or this object inside this one class and nowhere else. Is a derived class outside of this current class? Yeah. But do I necessarily want this function to be public? Do I want everything in my class to be public? Or do I only want some things to be public? We only want some things to be public, right? So there's kind of a chasm right here. I can't have everything be public, but I can't have everything be private either, because I want some things to be inherited by subclasses. So there is a third type called protected. So protected is a middle ground between the two. It says this function is not public, but any subclasses, it's visible to them. So any subclass like ASU instructor, they have access to this, this function f. But nothing outside of this inheritance chain has access to it. So if I had a different class out here that it doesn't inherit from either ASU instructor or ASU employee, it won't get that function because it's protected here. So protected is a third type of access specifier because we have inheritances here. And we don't want everything to be inherited necessarily, as was asked before, but we don't want everything to be public either. So we need to have this middle ground. So it's similar to private, but derived classes have access to it. Okay, so the base class access specification determines how the members of the base classes can be accessed by derived ones. So you may have noticed that we have put this public right here, and you may wonder, okay, why do we have public there? So there are three inheritance modes. So you can inherit everything publicly using public inheritance, protected, or private inheritance. So you can change the access specifier here in three different ways. So how does this actually work? So here's what happens. So it's not the same thing as when you put protected or public inside the class. This is different. So the base class access, which is the one you put outside right here, which is the three different ways I just mentioned, that's how you say, when I inherit something, how is it going to be accessed from then on? So if I do a public inheritance right here, then everything that's inherited from parent is automatically public by default. but then I can change it inside the class as needed. So the member access specification, which is what we've been doing all along, determines access for individual members of the class. So here, I'm publicly inheriting from parent. When you do inheritance, the vast majority of the time, you're going to do public inheritance because it's the one that's most used. But maybe sometimes you want protected and private. Usually you want public here. But the one that you will change most often is the member access ones. So this int A can be accessed by any subclasses of the child class. Question for you. For this variable A right here, can it be accessed by any arbitrary parent object? No. So I'm declaring this to say any subclass of child can access this variable A. But a parent object, not necessarily, because I'm inheriting from the parent class, is redefined in the child class. But, and I have a constructor here. Okay? So, any questions on inheritance so far? Okay, so you may wonder, okay, well, the things that we've been doing in classes the vast majority of the time are making constructors. We talked about all kinds of constructors and destructors. So how does that play into the inheritance game right here? So the derived class's constructor can be said to say, what base constructor am I going to call? So the derived constructor can say, I'm going to call this base constructor. And then what will happen here is the derived constructor can say, construct all of the things I inherit automatically for me. And then otherwise, I can do the class-specific things in my own class. So how would you actually do this? Oh, okay, so it doesn't actually say. So how would you actually do this? So let's just say that all I have in an ASU employee class is a constructor. Okay? So just a normal constructor. What I could have in the ASU instructor class is to say instructor. Okay, so how do we actually don't know. So let's just see. How do we initialize superclass C++? So I don't actually know the exact way to do it. Okay, so let's see. Okay, so the way that you actually do this is through the member init list. Okay, so remember init list is where we have this colon right here, and then we can construct any of the class variables this way from here. But here I can say, I'm going to do this constructor of the superclass first, then I'm going to execute the code inside here. So maybe we have in the ASU employee class some protected string s, and then we can say s is no name by default. And then here in the ASU instructor class, I can say s is equal to instructor, for example. So what'll happen here is it's going to call this constructor first, the base class's constructor, the one where it says s to no name. And then it's going to initialize s to be instructor. And we can actually see this in action. So we can say, we can print initializing s in base class. Can't type. And then we can have in here, down here, we're initializing s in derived class. And then maybe we can just make the instructor, and then we can see what happens. So we can actually really see it really is calling the base class's constructor because we put this cout statement in the constructor, and then it prints here because when we're done with the base class's constructor, then we do the normal constructor in the derived class, which is instructor in this case. Okay? So that's how constructors and in fact destructors work. So for destructors, what will happen is if I have a destructor for the instructor class, we can have it call the destructor for the employee class first, then resume execution inside of the destructor for our own class. So this is really nice because I don't have to initialize anything differently, any of the original variables. I just only need to initialize the ones that are different in the derived class. So I highly recommend using inheritance because it reduces this code duplication, and where a lot of duplication occurs is when you have constructors and destructors. One thing that I'm not actually sure of, and I encourage you to look up, is what about overloaded operators? So if I have an overloaded operator for a base class, does the derived class get the same operator? I believe it does, but that'd be something really cool to look up. But anyway, so this is basically saying what we've been doing so far. So if I have an undergrad object which inherits from the student object, then what will happen is when we do this constructor in the member init list business, it's going to go up into the superclass first, do all the construction up there that's necessary, then come back down into the derived class, and then finish the derived class's constructor as needed. So here, it's going to go up to the student constructor, then come back down into the one that we are worried about right here, which is the undergrad constructor. Then I actually had this backwards. So when we destroy this object, it's going to start with the lowest in the inheritance chain, the undergrad object, and then it's going to go up until it reaches the top of the inheritance chain, which is student in this case. Any questions about inheritance at all? So I highly recommend inheritance, but one thing that we're going to look at next is something called polymorphism. So one of the annoying things about inheritance is if you, for example, have a vector of ASU students, for example, and then if we had some function f on all of the objects that I put in here, so maybe I put in a sophomore student object and an undergrad object, graduate object, postgrad, a freshman, that sort of thing. But the vector that I've defined this over is only ASU students, the superclass, not the derived classes. So let's just say that we have some function f that's defined in the base class, so all the derived classes get it too. And let's say that I have this vector of ASU students, the base class, and I call f on every single one of them. What do you think is going to happen? So is it going to call the base class or the appropriate derived ones? So let's just look at this, for example. So let's just say that I include vector. Let's get rid of this because we don't actually need it. And let's just have a simple ASU employee and ASU instructor class. So let's just say that, actually I do need this. So let's just say we have a function f in the ASU employee class. Nothing special there. And let's just say that we have a vector of ASU employees. And then let's call them employees. Then maybe, for example, we say for every employee in this list of employees, we're going to call employee.f. Okay? Let's move this down a little bit. So this function f is defined in the employee class. And then maybe down here, I have the same function, but it does something different. Okay? It just does something different. What do you think is going to happen? Well, there's nothing in this employees vector. But let's just say we populate it with ASU employees. What do you think is going to happen? which one is it going to call? Is it going to always call the F up here in the employee class, or sometimes come down into the instructor class? It's actually going to always call the superclass's F function. And the reason for that is this vector is only defined over ASU employees. So when it encounters an ASU employee, it might be an instructor, it might not be, it'll always call the one that it's definitely defined for, which is the F up here, because it doesn't necessarily know, should I call the derived classes function, or should I call the superclasses one? By default, it's going to stick with the superclass one. But this is kind of annoying, right? If you had these functions do different things, then I want it to do the right thing for each of the employees. For the instructor, if it's an instructor, I want it to do the right thing for an instructor. If it's an arbitrary employee, then I don't want it to do that specific thing. I want it to do the general thing. Maybe we have a research scientist as an employee, and I want it to do differently than what the other two did. I want it to adapt to what object I put in, what derived class I put into this employees class, this employees vector. So that's where polymorphism comes into play. So polymorphism, so here is just an inheritance chain. So we have an animal superclass. Cat and dog are inheriting from the animal class, and poodle is inheriting from the dog class only. And of course, if you're lower in the hierarchy, there's special cases of the ones above because it's an is-a relationship. So we can make a pointer to an animal object, but the animal object that we made is a cat object, so a derived class. Okay? But I could change this to be dog or poodle or whatever, and I don't have to change the left side, which is kind of nice. But the annoying thing, okay, so let's see. Okay, so I'll return to those other slides when we come back on Monday. But the annoying thing is when you have 3 different implementations of the same function that do different things, but when you have an array of them and we call this function on them, it does only the superclasses function. And so we want it to be able to adapt depending on whether we have an animal, whether we have a dog or a cat or a poodle or whatever. So yeah, so it prints the exact same thing every single time. So polymorphism is a way of handling these different cases all at the same time, and you don't have to really do anything different. So how do you actually do this? If you make this the function in the superclass called virtual, then what that is a horrible name for this, but virtual says, I'm going to check the type of the object, whether it's the base class or the derived class, and then figure out which one is it. Is it the base one or the derived one? If it's the derived one, I'll do the derived function if it's there. I'll do the base one otherwise. Okay? So if we actually do this, it actually does the right thing. So if we go back to our example here, let's just say we print employee here, and then we print instructor down here. Let's say that we employees dot pushback, and I'm going to make ASU employee object into here. And then I'm going to push back and then ASU instructor here. So if we print this, hopefully this works. Yeah, so it printed employee twice because it's by default calling the superclass, which you may want, but it doesn't really seem like a good idea most of the time. So if we make it virtual instead, then if this, I thought that would work. Clearly I need to, okay, so you actually do need to call it virtual every place, unfortunately. But if you declare it virtual, so why did that not work? Interesting. I'll look that up and I'll fix it for Monday. So I'll see you all on Friday.